Hello, welcome to the second video on Arclength, where we go over just one example, but it's a difficult one. We have the curve that has the following description to it. The x component is t squared sine of 2t. The y component is t squared cosine squared of t squared cosine of 2t, and the third component, the k or z component, is root 3 t squared. Interested in finding how long it takes to walk along this curve. How far have you traveled if you walk along this curve from t equals 0 to t equals 2 square root of 3? We have the formula for arc length. That's found by first going and getting the velocity vector and then getting its magnitude and then integrating that. Let's look at this velocity vector. It's quite a bit of work because each of the I and j components have a product of functions. The t squared times the sine 2t, the t squared times the cosine 2t. So each of those will require the product rule. There'll be two different terms there from the product rule. Remember now, you take the derivative of the first times the second plus the first times the derivative of the second. I have it in pink here when I took the derivative, and then in green when I took the derivative of the second part. The I component's derivatives are in pink. The j component's derivatives are in lime green here. T squared's derivative is 2t. Leave the second alone. Then you have plus t squared, and you take the derivative of the second, which is sine 2t's derivative is 2 cosine 2t. Moving to the next component, t squared's derivative is 2t. Leave the cosine 2t alone. Put the plus. Leave the t squared alone. Cosine 2t's derivative is negative 2 sine 2t. Third component, just a power rule, 2 rad 3 times t. Here's where it gets bad at. You see, there's really no way to simplify that. Like, nothing cancels out. We possibly could factor out. Each of these components will have a 2 in it. We probably could take a 2 all the way out. But let's leave it as it is, because it's our job to find the magnitude of this vector. Maybe clean it up a little bit by making the j component just be minus 2t squared. Looks a little strange there. But yeah, we're going to square each component, add them up, and take a square root. I put the last part in purple so I don't forget it. The first part squared. We're going to work that out. Second part squared. We're going to work that out. And there'll be a lot of combining we can do with those two. But then there's still this other part, which is from the k component. And so let's square out the first component. So we have 2t sine 2t and 2t squared cosine 2t. Multiply that guy by itself. We'll do FOIL. Starts off with 4t squared sine squared 2t. And then there'll be two middle terms. You'll have 4t cubed sine t cosine t. Another 4t cubed sine t cosine t from the outer and the inner. They will combine to give you 8t cubed sine 2t cosine 2t. When you multiply the last guys together, you'll get 4t fourth cosine squared 2t. All right, great. Now, there's only a slight change with the second set of parentheses that is squared. There's a minus, and the cosine and sine are flipping spaces, but the concept is still the same. We'll FOIL it out. I'll color code it the same kind of way. From f, we get minus 4t squared sine 2t. Then we'll have wait a minute. Oh, I'm sorry. For f from FOIL, we get the 2t cosine t and the 2t cosine t. That's how we get the 4t squared cosine squared 2t. And then the middle terms have a minus on them now. We have a 4t cubed and another 4t cubed that are both negative. And then you still have the sine 2t cosine 2t mixed term. So those guys are negative 8t cubed sine 2t cosine 2t. From L, you'll get a negative 4t4 sine squared 2t. I color coded these nicely. We're going to add these two parts together. Okay. In the blue, if we add them together, we'll have sine squared plus cosine squared, which will be 1. So it'll just be 4t to the 4th. The middle terms cancel out. And for the red, the last terms will have same kind of sine squared plus cosine squared when you add them together, factoring out what they have in common there, 4t to the 4th. These are the elements that are underneath the square root. But don't forget that there's also that 12t squared. Whew. Okay, all right, we combine 12t squared, 4t squared, that's 16t squared. Plus the 4t4th, and we can factor out the 4 and t squared. They both have it in common. We won't factor it all the way out. First we'll just have it factored out inside, and then we can later pull it out. Okay. So we have 4t squared. We're left with 4 plus t squared. Taking the square root of 4t squared, we get 2t. But the root is still on the 4 plus t squared. That is your speed. You give me a time t, starting at 0, our speed is 0. But as t increases, our speed will increase. And we're not allowing for negative time t here. If we allowed for it, then technically I would have needed an absolute value bar around the t on the outside. All right, this is what we integrate for arc length. Now we have no more room on this slide, so we'll go to the next slide and continue this. The t bounds are 0 and 2 pi over 3. And the simplified form of everything we had from that last slide is 2t the square root of 4 plus t squared. And now we need to integrate this. It's not a perfect square like we had in the other ones. So we have to actually consider different techniques of integrating. We don't have to get too far down the rabbit hole of integration techniques. Integration by parts is not what we need here. This can be done with the use of. The inside power is 1 more than the outside power. In fact, the inside's derivative is the outside. If you let u be 4t squared, du is 2t dt. So you're just integrating the square root of u, or u to the half. Power rule in reverse, you add 1 to it, you get u to the 3 halves. You divide by 3 halves, but same thing as multiplying by 2/3. That's some side work to help you figure out that the antiderivative of 2t rad 4 plus t squared is the 4 plus t squared quantity raised to the 3 halves power times 2/3. So we can go back with the original t values, 2 rad, 3, and 0. You put the 2 rad 3 in, you square it, that's your 12 again, plus the 4 is 16. So when you put a 2 rad 3 in, you get a 16 who's raised to the 3 halves, and then you put a 0 in, you get a 4 who's raised to the 3 halves. These are nice perfect squares, so you raise them to the 1/2 first by taking the square root, and then you cube them. Square root of 16 is 4. 4 cubed, 64. Square root of 4 is 2. 2 cubed, 8. 64, take away 8, 56. But then you double that to get 112 over 3. Okay. Okay, here's the visual. So t goes from 0 to 2 rad 3. When t equals 0, you're at a height of 0 because the k component is 0. And can play again. I wish I could make it loop. But yeah, that's the path. And the length of that path is 112 over 3. Okay, just under 40. All right, great. So this ends this video. Thank you for watching. My name is Nakia Rimmer, helping through this multivariable calculus journey. Please comment down below. If you have any questions, please reach out to me. And please like and subscribe. I'll see you in the next video.